Hello everyone, welcome to this channel. Now, today we will discuss what is neuron. So, this is a neuron structure, and McLuch is a neuroscientist, and Pitts is a logician. Both are proposed neuron in 1943. So now we will see how this neuron structure is exactly works. So here the inputs are excitatory or inhibitory. These are inputs. The inputs should be in binary format only, whether 0 or 1. Excitatory means common inputs only, but inhibitory is like it means it's like a not yet, like this. This is a x1 input. If you give input as 1, it converts to the 0. If you give input as 0, it will convert to 1. So how the inhibitory inputs exactly will work. So now we will see. Here G is a function. G function aggregates all the inputs, and F is a function. F takes decisions based on G function. So Y is a output function, whether output is 0 or 1. So now we will see how G function and F function will work. Here uh, output is 0 if any one of input is inhibitory. Output becomes 0 if any one of input among these inputs is inhibitory, then output becomes definitely 0. Inhibitory means it has a bubble here, like bubble, like same not yet. This is what exactly neuron will work in this case. So now next, G aggregates all inputs, and G function is equals to summation of I is equals to 1 to n xi. So G is a function. G aggregates all the summation of all the inputs. This is what G function will work. Now we will see the F function. This is the F function. F takes decisions based on G function. So this is nothing but output only. So if output becomes 1, if G function greater than or equals to threshold value. G function greater than or equal to threshold value. In this case, the output becomes 1. If output becomes 0, if g of x less than threshold value. Now, g function less than threshold value, then output becomes 0 only. So this is just a basic structure of neuron. How it will work. This is just idea about the neuron. Now we will discuss by using some logic gates and operation and not operation. Now we will see. Now we will see the structures of logic gates and OR and NOT operations. Structures of logic gates of neuron. Now first OR gate. This is threshold value. This is a function. This is output. Now we are using only two inputs here, x1 and x2. Here threshold value is 1 in OR gate. In AND gate, this is threshold value, this is f function, this is output. Here also we are using only two inputs, x1 and x2. Here threshold value is 2 in AND gate. And now NOT gate. This is threshold value, this is f function, output. In this case, we are using only one input, that is x1. Here there is a bubble is there. This is a NOT gate. Here threshold value is 1. So here you can use any number of inputs, but for a simple example, I am using only two inputs here. So this is threshold value 1 for OR gate and 2 for AND gate and 1 for NOT gate. So now we will discuss one by one and each and every logic gate in detailed manner. Now we will discuss. Now first we will see OR gate. OR gate threshold value is 1 and this is a f function. This is output. Here I am using only two inputs, x1 and x2. So here first a neuron splits into two halves. Here a straight line is cutting exactly two halves on the graph based on 4 points. Those they are 0, 0, 0, 1, 1, 0, 1, 1. So in this case we are using only two inputs. That's what we have a 4 points. Based on these 4 points, a straight line is cutting exactly two halves on the graph. Now we will see how the graph will work. And here one side of the line output becomes 1 if this condition is satisfied. And another side of the line, the output becomes 0 if less than threshold value. So these two conditions are one side of the line. This is a, for example, just by roughly I am saying this is a graph. This straight line is cutting exactly two halves. One side of the line output becomes 1. In this case, if this condition is satisfied, and another side of the line output becomes 0 if this condition is satisfied. Now we will see. Now we will see how OR gate is exactly satisfies those two conditions. Here we are taking two inputs. That should be I is equals to 1, 2, xi greater than or equal to 1. 1 is threshold value. In this case, the output becomes 1. In this case, the output becomes 0. Now we will see the table of these two inputs. 0, 0, 0, 1, 1, 0, 1, 1. Here 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 2. In this case, this is less than threshold value. So less than threshold value, in this case the output becomes 0 only. Here output becomes 0. These three outputs are greater than or equal to threshold value. So in this case the output becomes 1. So this is what exactly OR gate will work. Now we will see. Now we will draw a straight line on the graph based on these four points. This is x1, this is x2, this is 0, 0, 1, 0, 0, 1, 1, 1. So these 4 points on the graph. Here we are drawing exactly on these lines. We are drawing a straight line exactly on these lines because above this line output becomes 1. Below this line output becomes 0. Because below this line only one point is there, only one point. In this point only output becomes 0. So above this line 3 points are there, 0 comma 1, 1 comma 0, 1 comma 1. Above this line 3 points are there, so that's what output becomes 1 only. So this is line equation. X1 plus x2 is equals to 1. Whatever the points are there on this line, you just substitute in this equation, the output becomes 1 only. So this is what exactly OR gate is working. So now we will see AND gate also. Now we will see how AND gate will work. So this is same like OR gate only, but here threshold value is 2. Now we will see how those two conditions are satisfied AND gate. Here x1 plus x2 is equals to summation of equals to 1 to xi greater than or equal to threshold value. Threshold value here is 2. In this case, output becomes 1. And x1 plus x2 summation of I equals to 1 to xi less than 2. In this case, output becomes 0. Why I am taking 2 here? Because we are using only 2 inputs. So that's what I have taken 2 here. So we will see the table. X1 plus x2 0, 0, 0, 1, 1, 0, 1, 1. 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 2. Here 0, this is less than threshold value, and here also 1, this is less than threshold value, 1, this is also less than threshold value. In these three cases the output becomes 0 only, because this is less than threshold value. In this condition output becomes 0 only. Here output is greater than or equal to 2. In this case output becomes 1. uh, in this case the output becomes 1 only, because this is a greater than or equal to threshold value. So now we will see how these 4 points representing on the graph. This is x1, x2, 0, 0, 1, 0, 0, 1, 1, 1. This is 4 points. Here I am drawing a line based on these 4 points, but here I am drawing a line exactly, output here is 1. So here I am drawing a straight line here, because above this line output becomes 1, below this line output becomes 0, because in these 3 points output becomes 0 only. So that's what we are drawing a straight line here. Above this line there is a 1 comma 1 point is there. In this case the output becomes 1 only. So this line equation is x1 plus x2 is equals to 2. So any point on the line, you just substitute that point in this equation, the output becomes 2 only. So this is what AND gate is working. Yeah guys, if you really like this video, please subscribe our channel. And yeah, mostly I have covered everything, and in detailed manner. I think this information is enough for all any examination, and gate exam, and your semester end semester examinations, and other competitive examinations. So I think this information is enough guys. I explained each and everything in detailed manner. So that's it, that's about this video. So if you like this video, please subscribe our channel guys. So actually your support is our motivation only by doing this such a quality content. So thank you guys, and share this video as much as is possible.